Awesome. Hope everyone finished to read the ISTQB syllabus. I think Georgiana has some more questions prepared for you today. And then I think we are going to switch to Radu to give us a glimpse on how we can write test cases using LLMs. If I'm not mistaken, this is the agenda for today. So yeah, first of all, does anyone have any questions related to whatever they read in the last week? If nothing, then I think Georgiana, you can take over and walk us through.
Yes, hello everyone. I saw Alex. Alex, I think he's here or had a question related to in the chat. I ask you back. It's related to one case there. Are you asking about acute triangle? Or we continue that in chat and we will go. We will start with the examples.
Yeah, let's go through
Let's get started.
through the examples, because that being on the chat and this call being recorded doesn't
okay.
really.
I'll share my screen. Can you see my screen?
Yes.
Okay. So I prepared some theoretical question and also some practical ones. These are again 6 questions. They are from chapter 5 and 6 that was remaining from the last ones. We'll start with the first one. According to the testing quadrants model, which of the following falls into quadrant Q1, technology facing and supports the team? We have A, usability testing, B, functional testing, C, user acceptance testing, and D, component integration testing. So let's see first if you want to try to give an answer. D. Yes, that's the correct one. Component integration is technology-facing testing that supports the team, guides the development. The second one, yeah, we can see the other ones. Also, the first one, usability testing, it's part of Q3. Then we have the functional testing that is part of Q2. And C, user acceptance testing, this is part again of Q3. So this is the only one part of the Q1. The second question, the team uses the 3-point estimation technique to estimate the test effort for a new high-risk feature. The following estimates were made. Most optimistic estimation, 2 person-hours, most likely estimation, 11 person-hours, and most pessimistic estimation, 14 person-hours. So here is a bit of math related to this formula. So let's see, the final estimate would be A, 9 person-hours, 14 person-hours, 11 person-hours, or 10 person-hours. If you read on chapter 5, you can find this formula, and I can give you a hint, like the most likely estimation is going to be more than the other ones, and it's like, if you remember in math, we have like ponderate. think that's the name in English, ponderate media. I'm not sure. Any answers? Yeah, I see Alex D. Yes, so this is 10 person hours. And can you tell us also the formula here for the estimation? This is the most optimistic estimation. It's 1 plus 4 times the most likely estimation. And then for we add again the pessimistic. And we divide by 6, which is going to come to 10, our response. Yeah, divided by 6, not by 4. Yeah, sure. Okay, good. The next one. 3, you are testing a mobile application that allows the user to find a nearby restaurant based on the type of food they want to eat. Consider the following list of test cases priorities. For example, a smaller number means a higher priority, and dependencies. So we have test case number 1, TC001, select type of food, priority 3, logical dependency none. Test case 002, select restaurant, priority 2, TC001. TC003, get direction, priority 1, logical dependency TC002. TC004, called restaurant, priority 2, logical dependency TC002. And test case number TC005, make reservation, priority 3, and logical dependency TC002. And the question is, which of the following test case should be executed as the third one? And we have A, TC003, B, TC005, TC002, or TC001.
I think I'll go for D.
There were 3 Ds already. It's not D this time. This 001. So the question is, which one is going to be executed, the third one? Which test case? TC001, it's going to be the first one. Why? Because it's based on the type. So if we read at the beginning, the testing mobile application allows users to find based on the type of food they want to eat. So that is going to be the first one in order. And then if we go, the second one will be to select the restaurant. This will be the second one. And then the third one will be to get direction to the restaurant. So this is TC003 is the one that should be executed, the third one. Is it clear? Why is this? Yeah, I see now on A there from Alex. We'll go to the next one. 4. You are a member of a test team located in North America, developing a product for a client located in Europe. The team is agile and follows the DevOps approach and uses a continuous integration, continuous delivery pipeline. Which of the following is the least effective way to communicate test progress to the customer? A, face-to-face, B, dashboards, C, email, D, video conferencing. So this is really actual in the QA, because usually the team is all over the place. Not all the time, but It happens. So any answers? This should be easy.
See.
Is email like the least effective?
I don't know what dashboards refers to, but I'll go for C.
Dashboard is like when it's available every time, like a document, like a, no, what can I say? The dashboard, yeah. A dashboard, like, yeah, like if you have an access to it, you can access it all the time. So that's the idea. So it's like effective in the case you are in different time zones, because you just look at it and then it's offline.
It's a place where information aggregates live, and you don't have to do anything. You just take a look at it. It's like a dashboard of a car. When you drive, you see different information about your drive in real time. That's that's what a dashboard
Like a display,
does.
no?
Oh, okay, thank you.
Yeah, so dashboards are effective because like it's the same for me and for someone in Europe, like you see the same thing in the same time. The same, I see email, another option there. Email also, like, doesn't matter if I'm in a different timeline, I can still see the email at my time and respond, like it's still effective. Also, like, let's see our meeting, like a video conference, like a conference, this is also really effective because I'm in Canada, some of you are in Europe, in Romania, I don't know others. But like we still are here. Like for the least effective, it's face to face, because to have a meeting face to face, we have to fly in a place to meet all together. So A is the least effective way to communicate.
Until they discover the teleportation device, you know.
Oh, that will be great. Yeah, that will be great. Okay, 5. You received the following defect report from the developers stating that the anomaly described in this test report is not reproducible. And here it's how they're presenting. It's not like a regular presentation. So I leave it how it was in the STQB example. Application hangs up. 2022, May 03, John Doe rejected. The application hangs up after entering test input, some characters, in the name field on the new user creation screen. Try to log off, log in with testadmin01 account, same issue. Try with other testadmin accounts, same issue. No error message received. Log, see attached, contains fatal error notification. Based on the test case TC1305, the application should accept the provided input and create the user. Please fix with high priority. This feature is related to requirement 0012, which is a critical new business requirement. And the question is, what critical information is missing from this test report that would have been useful for the developers? A, expected result and actual result. B, references and defect status. C, test environment and test item. And D, priority and severity. So one option is correct. Let's see. Is this, yeah, C? Yeah, that's the one that is correct, because we have an expected result and an actual result. They say like, what does it say? Should accept, so here should accept the provided input, like this is the expected result, and then we have the actual result that the application hangs up or something. And then priority and severity, they also mention in the last sentence. So what we are missing here is the test environment and the test item. And the last one, which of the following is most likely to be a benefit of test automation? It provides coverage measures that are too complicated for humans to derive. B, it shares responsibility for the testing with the tool vendor. C, it removes the need for critical thinking when analyzing test results. And D, it generates test cases from an analysis of the program code. Any ideas? So no ideas, no. See, it removes the need for critical thinking when analyzing test results. Yeah, this is not the correct, not C. Yeah, but Raluca, it's right. A is the one that is correct. C is not correct because testers will still need to perform critical thinking when they analyze anomalies in the test results. And A is the correct one. It provides coverage measures that are too complicated for humans to derive. It's like a white box text coverage measures for all but the most trivial code. That's what we have here. Okay, so these are the questions I have for today. I'll send, actually, I will just send the link. I'm not sure if you have it from the last time, where you can find even more examples if you would like to prepare for the ISTQB exam. And that was all. If you have any questions, yeah, I will answer in the chat to the question in Discord for the question there.
Thank you, Georgiana. Any questions from anyone? Because if not, we'll ask Radu to continue. All right, Radu, you have the floor.
Thank you. I'll share my screen. Can you see my screen?
Yes.
Yes.
Okay. Let me see the recording. Okay, so how automation helps is, for example, you have a lot of test cases that normally are to be run on every product release. Let's say you have the WhatsApp application, for example, and when they release a new version that you have on your phone that you see that is an update or something, they try to make sure that they catch the issues internally. So they are using manual testers to run all these test cases that they define to make sure that the application runs correctly. And at every release, they run all these test suites, and it can become very tedious. That even for the testers, it could become, let's say, a bit boring that you run the same tests every, I don't know, few months, or when they release, even earlier. And it would be nice if some of them you could automate. So you put the technology working for you. So for example, there are ways that you can use some programming languages or some scripts, let's say, that are some let's say particular instructions that you can write, and then your manual steps that normally you do could be performed by a computer program. And this is what is called automation. So maybe for some tests that you need to run them, to takes you, I don't know, maybe 1 or 2 days. If you have some automated programs that run those, maybe it could take you a few hours. And every time then on the release you can run those, and you can use the power of manual tester, for example, to do all kind of exploratory testing, so to discover different flows that they haven't analyzed, let's say, for no, and until then, and actually let the machine and technology do the boring stuff. And this is where also ChatGPT is something that it can be very helpful, because knowing so ChatGPT was learning on a very big let's say data set. So they learn from internet a lot of stuff, and then they also uh, somehow have the ability to understand. So ChatGPT has the ability to understand and generate code for you. And one example for is you could have so what normally happens without, let's say, ChatGPT, or in a in normal environment where the automation person writes the test. So the normally the automation uh, the guy knows a bit of programming, so he knows some scripting or some programming language, like for example, maybe you heard of Python or Java or JavaScript, Kotlin, or I don't know. And he takes the steps that the manual QA created, and he writes in a program. He translates those in a program where that program can then be run automatically. And uh, in order to do that, okay, in that case you need to know a bit of programming. But given that we have this marvelous tool called ChatGPT, and it can generate a lot of stuff for us, uh, many times, let's say, unuseful stuff, but it can also be used to generate something very useful. So, for example, here on the left, I have a very simple application. Let me first describe the application. So, I have an application which gives you the ability to have a folder that you can encrypt. So the data on that folder, let's say, is encrypted, and nobody can see what's exactly in there. But you also have a way to view the data like in a regular folder. So for example, here is the data folder that uh, creates the data in encrypted format, and in the final folder I have the data that I can see as regulars. For example, if I create here a file, I put something in the file. This is what you see as a user in the decrypted format, in the normal format, and the actual encrypted format, it looks something like this. So you see here some IDs, you see here some scrambled data. So this should be the file name that was A. So in this case, is like this, and this will be the content. So it's not nothing like you created. So this is a good application to test and to do automation, because the the way you so for you to understand what the application needs to do and how it should perform, You just need to understand that this final folder is like a regular folder on your disk. So behind the scenes, this does the magic of encrypting and decrypting what's here in the data folder. But you here see exactly like a regular folder. So you could imagine test cases, various test cases, what you would actually do with a regular folder on your system. So just creating files in there, copying large movies, or I don't know, anything you can imagine. So it's very common operations for you. So you did this a lot of times, so it's very easy for you. So there are not much to, let's say, explain and requirements and specifications and stuff like that. What this should do, and also it's very easy that all this, for example, if you look here, it started in a browser. So actually, behind the scenes, it's running on the GitHub is running a Linux image in a Docker container, and so it's like running a computer for you. And this starts the application there. For example, this is the application. Let me. So this is how the application runs. So this is like a command line application. I know maybe some of you are familiar. So it's like an application that you can run from I think Windows is you press or start run and press and write command, and then it gives you like a terminal where you can write commands. So this application is without the UI. So it actually performs all this encryption and decryption magic behind the scenes. So long story short is that you have a folder that should perform like a regular folder, and behind the scenes that does encryption. And you can imagine test cases, for example, here, very basic test cases. Let's take, for example, this one, create an empty folder. So the steps are in the final folder where we view. So the final folder gives you a view of the decrypted data. So this is the all operations are relative to the final folder in this case, and we just create a folder there, and the expected results are just to make sure that that folder A that we created is present in there. And also there is this concept of logs that you'll encounter many times. So application print different messages for the developers to be able to see what happened, so that it could understand the issue and have additional information, more than you can actually just, I don't know, see on the screen or tell them by what operation they do. So, for example, these kind of lines that you'll see are called logs, and when you see green and other colors than red is good. When you see red is bad. So if you have logs that are colored, it's important. You as you've seen the needed information when you open the bug is like environment and device and stuff like that, the application version and something, screenshots or video if you have. It's also very important if you can get hold of this. Actually, these are the most important for a developer, because here is like application speaking to the developer, let's say, and I can see what application actually did. And the red ones are actually which could contain the most of the information with related to the problem, and could help the developer to resolve the issue. So just make sure if you have these, include them. And for now, let's see how we could actually generate a test case. I mean, from a test case, how could we could generate some Python code that can actually run our test case. So as you know, you need to have some ways of speaking with the ChatGPT and instructing it to do what you want. So, for example, you could use a query like this or message like this. So create a test case in Python for a file system following these steps that will enumerate below, and expect the results, which is the classical test case format. All operations should be made relative to folder with name final, as we seen earlier, This, let's say, ignore for now. It's a bit more technical issue, but it's just instructing the ChatGPT, let's say, not to be so technical, and it generates for you and to generate for you a more human readable code, which for you in this position now, it's very important to understand the logic more than the technicalities behind the scenes. So just let's say you are using this phrase and later on you will understand it, but this is important, the first two, and this will contain the steps, for example, here, and the expect results. You can use this as a template. You can just save it somewhere, and then we'll take from here, for example, take the steps to the steps. We just put in there, and then the expected results. Then we go to ChatGPT and just ask it. You can play with several, okay, depending on what plans you have or something. You can play with several, let's say, types of GPTs here, but the default one should suffice. So you see, it generated some code. So let's not go into details. We'll go in a bit. Let's just say we copy this code. We just go into our program where we have the, let's say, other tests. So for example, here in the test, this is we just create a file for now that will contain our test. So this is for the Python language specific. So depending on the language, for example, the extension of the file will be different. Maybe also the structure of the file will be different, but just for the simple case, let's say we create this file test1. We just put the text there, the code there that was generated. Let's say we don't care for now what it does. And then the way you run Python tests, so this is also a particularity to Python, but it doesn't matter for now. You just specify the file, for example. And this will run the test, and like I said, the green is good, red is bad. So let's hope that the God of Demons are okay, and we'll all see green. We see red, okay. File exists, okay, this is okay, because I did some tests before. So normally what happens, maybe it's a good example to just tell you for the future. So normally what happens here is I try to create, if you look at the test case, a folder named A, and actually that file was present already there. And of course it couldn't create it, so it failed. So this is, let's say, is a good is a good fail. How could I say? So it's good that it failed, because normally you cannot create a file with the same name twice. So what's normally happening is when you create such a test cases that run automatically, first you clean your environment. For example, this final folder, you clean it, you make it empty, and then you run your tests. You will see later on, because it's relevant, because if not, you can work with, like, say, garbage data from others, and it will mess up your test. But it's actually not relevant, because it will be like a false positive. False positive means that you discover a problem, so that's the positive part. You discover a issue, but it's a false issue, let's say, because here there is no problem actually, because the test didn't fail because there is a actual problem with our code, but because actually the environment was in an invalid state, let's say. So it was not prepared correctly. So for now, just clean the environment. So normally this is like folder final is now clean. So now when we run it, green. So this is good. So now actually what it did, it actually performed these steps, go to final folder, create folder A, and then it checked that that folder A is present there. So in time you will learn various languages, various scripting, let's say, that you will use to write these tests, these automated tests. But for now, uh, it's important to understand that using ChatGPT you could create some tests that they could help you run your steps even if you don't fully understand what they do, what the code does. But it's important in time to understand, because it's tricky just to use this, because it could be like the code could, for example, let's say do nothing, or don't check actually for the situation that you need to check. So it could trick you, let's say it could lie to you that everything is okay. So that is what is called a false negative. So the negative part is that it didn't discover any problems, but that's actually false, because there could be problems, just that it didn't test them correctly. So in time you'll understand the languages, but just for now, I could explain a little bit what's happening here, because Python, it's a very, let's say, human readable language. It has a minimalistic, let's say, artifacts like characters and boilerplate code, other than expressing your logic. So you'll see that is not very difficult. And in time you could learn Python, but meanwhile you could even use ChatGPT to explain you. So if you go here, this explains you in a bit, for example, what's happening. But you could also ask him to explain more the code, and it will take parts of the code, even line by line, and it will explain what's actually happening on each of these. So you could understand better what it does. But for now, let me just explain you very briefly what the code does, because you'll see it's not complicated at all. So these import are not important. It's not important. Let's say for now, it's just we tell to the environment that we want to use some tools, let's call them. So these are some tools. So this test create folder is the, let's say, the steps that will execute. So this is like it's called a function. Maybe you're not familiar with what function is, but it's like a function in mathematics, for example. So it's like a collection of steps that will be performed and are grouped in this name, let's say. So this is like this is will be let's say this is like the operation, the big operation that will be done, and this is the name, test create folder. Normally the function name starts with test for a test for different reasons, not important now. So now we can see, for example, it takes the base path. The base path is where the files resides. So this is the final folder that we said that everything is relative to this. Then this is the folder name that we create. If you look here, we create folder A. So we just say create folder A. While we put it here, so we could just use A whenever is needed. But for example, if you see, it's used twice. So it's used also here on line 7, also here on line 18. So if I just decide to make this B, let's say, I just change it one place. So that's why this is called like a variable. So this is like, for example, in mathematics, the x and y that we are used to from equations and stuff like that. And this is the folder path is here is creating actually the path that this folder that we are creating will be. So normally it will be something like final slash or backslash for Windows users, final slash A. So that will be the path. In the final folder, we'll have another folder A. And this is just like an artifact that Python does. It's if you see, it's joining the paths, and these are the paths that are joined. So the base path, which is final, and the folder name, which is A. Okay, now it's actually creating the actually, this is just a test. I mean, this is just a sanity check. This line, it just makes sure that this final folder exists. But okay, in our case, it does. But it's just doing the help for us. So it's just making sure that this base path exists. Okay, so this you can see step 1 actually, and it's actually describing you what it does. Navigate to final folder, and this is okay, not needed, because it's using this folder path. It's also containing the full path to that A folder. So in some cases, maybe you want to go in that folder and do operation there. In this case, it's not important. And now is this step 2. This is actually step 2 from our test case. If you go into the steps, you can see create folder A. Create folder A, and this command make dirs actually creates a folder with this name, and this is actually the uh, final slash A in our case. So this creates the folder A, and this just says here, okay, another artifact, but it just says that, okay, I want to create this folder and exist, okay, is true. But just remember, it creates a folder with this path. Then here it tests, these are the expected results. If you look at the expected results, ensure folder A exists. And what it does here, it just checks that the path is a directory, and this is the folder that is checking, folder path, which is final slash A. And in case what's following is, in case that fails, so in case that folder A is not present there, this is the message that will be printed out. That folder name was not created successfully. And just for demonstration purposes, okay, I closed the wrong window. Let's wait a bit. I'll I'll force the test to fail just to see what happens when actually it's failing. So for example, here we could just say this, I don't know, folder path, put some, garbage here. So it's testing that this folder exists. So for sure this will not exist. And when you run the test, you can actually see this. Red is bad, as I told you. So you can see this first line of red is telling you that folder A was not created successfully, which is the message that you expect to see in that case. So here I force the test to fail. So here the actual code, let's say, executed correctly, but here the test is wrong. So in this case, the test is wrong because it doesn't check for A, it checks for which was created, it checks for a different name. But this is just to force for you to see how an error message is, because there are situations where it's a bit harder to make the real program fail actually. So which is good, let's say, because it's good if it's hard to make a program fail, because actually you don't want it to fail. And this actually is all the what a Python code looks like for the given steps that are human readable here on the left, and let's say the code here on the right. So please let me know what you feel about this. How do you see it? Do you see it very complicated, or do you see yourself being able to do something like that? Did you understood a bit what the code does here? You don't need to understand just now all of this. So you will understand in time. So like you see, if you go to ChatGPT, you can take individual lines if you want, and it can explain you any stuff. In time, actually, you could use this as a way to learn Python, for example. And you could also have a tutorial and stuff like that. So in parallel, you could actually dynamically and actively learn by example Python, which is more practical than just I don't know, reading some tutorials. But do you how do you feel? Do you feel it's very complicated, or is reasonable? Do you see yourself doing something like that, like taking some steps from a test case using ChatGPT and take the code and run it? Either is very easy, either is very complicated. Yeah. So yeah, from the chat from the beginning is much more easily using ChatGPT instead of actually you writing the code. Okay, this is what you mean. But the idea is that uh, it's possible that, and it's normal. It's not a problem that you never experienced, you never had, were not exposed to any programming languages or any scripting or stuff like that. So you don't have from where to know, to write some code, which is reasonable and it's okay. And instead of all this longer, let's say, process of learning the code, this is like a shortcut. Then it can actively make you learn programming and then use it. But if you are to do this by yourself, would you think would be reasonable for you to do it? Do you think you could do it? So just take the steps, use ChatGPT to generate, and then run it from what you've seen. Okay. Uh, we could do one more example, uh, a bit more complicated one, but not too complicated, and just to see how it is, and we'll see it's not very complicated. So let's say we take this test case that we create in the final directory a file called test, and we add the context text in that file, and then we check that that file exists and that the content is text. So it's not very complicated. So the same, we first start with the prompt, which was this, like the template. We could add the template in a new file. We then add the steps, and then we add the expected results. The expected results, we go here, copy them, put them here. What helps is when you are creating new, you want to generate new code for new test case, it helps if you create a new chat, because if not, it will use this existing chat as a context, and it will try to somehow merge them together and use information from the previous one, which in our case it doesn't make sense. We don't want that because these are individual test cases. So we just start a new one and just add as before. The same, it generates. Okay, we'll just wait to finish. Okay, just take it from there. We go to our running environment. And here we have another file, let's say test2. We add it here. And then we go and run test2. Let me first clear. So all these, like, okay, you're not familiar, maybe, I mean, of course you're not familiar what all these windows look like. So this is called like the code editor. So it helps you write your code, and you see it's like a file manager. Here on the left you have the classical tree that you have also in Windows Explorer with the files, and this is actually the what you see here in the left is the actual project that it's running. So that is doing encryption and exposing you this final folder, and this is the actual code. And alongside the code, normally in the same let's say folder in the same place, we also keep the tests. So because we want to keep them related and in a relation, that if, I don't know, we modify one, we modify the code, we modify the test too. So these are dependent. And okay, it's a bit too much for you what you see here, but just imagine these are what is called as a boilerplate. So it's or tools that are helping you, but the actual logic remains the same. So you just need a piece of code, which is this, that describe your test cases, your steps that you are running, and you need a way to run it. That's it. So all other stuff that you see here are tools that are helping you make this possible. So we'll I'll send you details with all of these. For example, there is I have a page where you can set up yourself all this on GitHub, so everything is explained. So it will be clear for you in the end how this should be done. But that's not, let's say, so relevant right now, because now somehow it is just helpful for you to understand that even though you don't know programming, you could still generate code and still do a bit of automation, and slowly in time, actually faster than learning from scratch the language using ChatGPT, you can actually get to the level of an automation tester. Okay, so we just added our new code, and now we run this new file, which is test2. Let's pray for the god of demos. Yeah, and it's good. Green again. Okay, so in these two cases, it generated, let's say, correctly code. It happens sometimes that you've seen that ChatGPT it's going insane with what it generates. Also, when it generates text for you, there is this concept of hallucinations, where it's actually, I don't know, inventing fictional characters or historical events that doesn't actually exist. So all this will happen also when generating code. So for example, it will generate for you, uh, let's say, functions or stuff like that, which actually, or keywords or something that are not present in Python, let's say. And in those cases, you can even use ChatGPT to fix those. And slowly, if you just ask him correctly, it will somehow understand and fix those problems. And in that manner, it help you also that in time you also understand what the Python code means, and at least what it means, not necessarily to write it from scratch, but then you can spot the problem. So this could be trivial problems. I don't know, in some cases it could write like this, write lines somehow instead of right, and this actually doesn't exist, but you'll remember that from somewhere you'll see that it was right, and you'll know that you can use that and correct it. But even more, if you're using tools like this editor, for example, you can see here that it's suggesting you what is the correct term, let's say, to use here. So you can actually see from here, and you see that it's right. So all this will come with time, but it's I think this is important to understand that you can generate this, for example, this new test case. That if you look quickly also here, you can now quickly understand that as before, we are just setting up our paths. So final dir, and then this creates, for example, this creates that file, create a file named test. So this creates that file test. So this is just the syntax sugaring. It open the file text for writing, and then it refers to the file as f, and then with f you can write in it, and you see it write text, and then here it checks that the file exists, test file exists, and then it checks for the content. It opens the file for reading, and then it reads the content, and it compares the content with the desired value that you want, which is text. So this would be how you could use ChatGPT to generate you code, and in time to also help you learn languages like Python, for example. If you have any questions. Okay. If not, then I'll send you all this, and if you want to give it a try to do some tests and create some test cases and then generate code for them, and feel free to ask. I'll try to help as I can. Okay, so that will be all from my side. If you guys have something else, please carry on.
Thank you, Radu. So, if anyone has any questions for Radu, feel free to address them now. If not, we'll adjourn in a few minutes.
So, like I said, either is you feel this is very complicated, or you feel this is very very obvious. In both cases, okay, in very easy case, there's not a problem, nothing to discuss more. But in the case you feel it's complicated, just understand that in time all this will be way more easier. And after you just understand all this, you'll see all these tools that are something like a skeleton that helps you. And when you'll focus on the actual logic and the code, you'll see that everything is much easier. And you will understand that, and you will see that actually this helps you. So uh, just imagine all those test cases that you've seen there in the document. So if I were to run those, execute those manually, maybe it could take like maybe 1 hour, let's say. But if I do this conversion to this Python code, most likely, given that they're not very complicated, not very large files, most likely it could finish like maybe under a minute, or let's say 5 minutes top or something like that. So it's very useful for you in the end, and it takes the burden of rerunning the same tests every release, for example, and you could focus on more creative tasks. So this is why tools are present to help us do the boring stuff. Let's say also technology is best if it helps us with that. There is a meme that says that I want I would want ChatGPT to do the dishes for me and wash the clothes and blah blah blah, and let me do the art and create music and stuff like that, not vice versa. And now somehow ChatGPT is mostly used for that instead of automating our boring stuff. But for example, this is a way you could use ChatGPT to make it practical and automate something that maybe is not so creative, and you could focus on something more creative.
All right, all right, people. If there are not any questions for Radu or for me or for Georgiana, I think we can close this meeting. All right, Radu, you can. I think you can stop the recording.
Yeah, sure.
Everyone, have a great rest of your day.